Welcome to Delivering Knowledge. In March 2024, we were delighted to welcome Tamryn Hassel to the Cherwell studio. Tamryn's a quality specialist with extensive experience in the field and shared with us her expert knowledge regarding the desiccation of agar plates. She tells us why desiccation is an issue, reasons desiccation occurs, and possible solutions to the problem.
Well, thank you for having me. First of all, I really appreciate it. My name is Tamryn Hassel and I work for a company called Microbiology, which I've just recently set up. It's a consultancy to the pharmaceutical sector, and what we do is we specifically partner with startups. So we look to support them from a onboarding training, QMS, development, and also consultancy side. And my background is that I started, as you can hear from my accent, I'm from South Africa originally. I studied out there. I did a degree in microbiology. And then I started my career here with a company called Patheon, where I worked in their QC microbiology department, specifically the environmental monitoring side. So that's where I was introduced to Cherwell. And from there, I moved up into a team that looked at sterility testing and bioburden testing. And from there, moved naturally into the quality assurance department at a new company, an aseptic compounder. There, I supported the team again in an environments lead role, again working with Cherwell. So come a long way with Cherwell at the start of my career. Moved into a quality and compliance management role, and at the same time studied an MBA. So the company was very kind to me. They allowed me to set up a sister company that sat alongside or sat within that group. And during my time with that company, we were developing an environmental monitoring software system as well as a rapid sterility test. So that was very exciting. From there, I moved into biologics and was with the biologics sector for about 1.5 years before transitioning to consultancy. So desiccation. It's an issue in industry because the agar plates are designed to maximize on the growth of any contamination that might be captured. And where you have any questions with regards to the variability of the quality of media, it then brings into question whether or not the media was suitable for the task that it was being employed for. So for example, if you're using it for environmental monitoring, and you now suddenly have evidence of desiccation, can you question the result? Is the result a true reflection of what was actually happening within the environment at the time that you were monitoring? So it's really about ensuring that the tools you're using for the task you're trying to execute against, which in this case is environmental monitoring, and proving that your environment is meeting GMP requirements, was correct. Everything was right and in place. So with agar, as I think many people will know, it's designed to have sufficient water and nutrients to support the growth of these organisms. Desiccation occurs mainly because of water loss from the media. So as soon as you reduce the water activity within the media, there's a risk that organisms won't be able to grow or won't be able to grow as quickly. And so when you are taking your plates out of the incubator a couple of days later, it could be that with reduced water activity in the media, there was insufficient time for those organisms to grow. So that's why desiccation is a problem within the industry. I suppose also you could argue that desiccation creates cracks in the agar as well. And so there's always a risk that organisms could fall within those cracks. Now you can argue you've got a giant clean room, I suppose, with organisms falling all around, but it does still just add to the questionability of the result that you have. So when it comes to desiccation, the main causes of desiccation, there can be quite a few. But the majority, I suppose, that people go, or the natural root cause that people will go to is hot, rapid airflow. So definitely what we term the hairdryer effect is caused within a clean room where you've got laminar airflow blowing across the surface of the plate that then is causing evaporation of the water from the media. It tends to be worse with laminar airflow, which within a cabinet or directly under a HEPA filter, for example, could be worse. But where you've got turbulent airflow, the same effect can occur. So those are two main reasons. Then you can have an issue with the storage of the media that can cause desiccation. So if you've got rapid temperature changes, so for example, if you've transported your media in a cool van, for example, brought it into a warm warehouse, put it into a fridge, and then taken it out into a warmer clean room, so to speak. You then have those temperature changes which can cause evaporation, condensation cycles within the media before it's used, and that can then also lead to water loss. So you can see desiccation as a result of that. Over-irradiation of agar can cause desiccation. So my studies have found that when you give too high a dose of irradiation to agar plates, it can lead to a structural change that then leads to desiccation. So the formation of cracks really is what you see. The slight variability of the raw materials and starting materials that are used by manufacturers such as yourselves, that can also lead to desiccation. So that's a far more nuanced reason for it. But it's worth, if you are having desiccation issues and you haven't been able to show that it's anything to do with the airflows that you are exposing your media to, that it's worth going back to your supplier and just asking, is there anything that they've changed in their process that might have led to this change that you're now seeing within your media. I think then one of the areas that I've personally seen in my career that has been a problem is where you have incubators that have very aggressive fan units on them. So a lot of the incubators you can buy now for the pharmaceutical sector specifically have variable fan speeds on them. And the reason for that is to try and control for too much airflow over the surface of the agar plate. Now you can argue that the agar plates are obviously closed when they're in the incubator, but they do have air vents and there is an airflow that's happening, and that can aid evaporation, which can then lead to desiccation. So that's definitely something I've seen, and it took us a long time to get there. So just be aware of that. When you do see desiccation, it's worth going and having a look at your incubators and just asking the question, do you have control over the fan speed at all? And if not, contact the supplier of the incubator and see whether the fan speeds are set to a maximum rate at all. And you can move the plates around within the incubators to try and determine whether or not that's causing your problem. So certain positions might have different desiccation rates, or you might not see desiccation at certain positions, but you might see desiccation at a specific position within the incubator then. Then you get something called particle bounce, which can aid desiccation. So if you're working in an environment where you are dealing with a higher particulate load, so probably like a powder manufacturing plant of sorts, or somewhere where they're working with powders, this is likely to be a problem, where the particles bouncing off the surface of the agar can actually increase evaporation, which then leads to desiccation. What you might see is certain suppliers have the ability to customize their media with the amount of agar that they're putting, or their specific recipe that they use might have a quantity of agar that within your environmental controls or your environmental setting, I suppose, is not suitable. So the agar content is too high, and because of the airflow over the surface of the plate combined with the agar, which is holding on to water within the media, that could be leading to desiccation as well. I guess an immediate solution that you could put in place if you are seeing desiccation is to see if you have alternate approved suppliers on your suppliers list. Bring those suppliers' media in and start to work with that, and hopefully that will resolve the problem. If you're still seeing the issue though, then it's worth considering whether you can double up the number of plates that you're laying out. Then you just need to have a very structured approach to how you address the results from any desiccated plates or both plates, for example, and it will be down to each site individually to decide how to do that. My suggestion would be, if you're putting both plates out, you should be using the results from both of those plates in accordance with what your procedures will say. Otherwise, short term, you could look to reduce the exposure time, because obviously the longer the plates are exposed, the more chance there is for evaporation. And so by reducing that exposure time, you are therefore reducing the risk of evaporation, which then leads to desiccation. The risk with that, though, is that if you are working in a critical zone, for example, it means more interventions into that zone now, because you're having to switch plates out more frequently. On a medium-term basis, you could look to alter the position of the plates within your incubator. So if you work at a site where you are lucky enough to have sufficient volume within your incubator, in order to store these plates, you could move around where you're storing them. Have a look and see whether or not that is improving the situation in any way, and will also indicate to you whether it's a problem actually with your environment or your incubator, as opposed to specifically being an environmental or a supply issue with your plates. You could also look to introduce the use of trays or boxes. Just bear in mind that you do still need airflow happening around the plates, so you can't seal them off entirely. And I've seen some sites use parafilm quite successfully again. but just consider that respiration requirements of your plates. So the longer you're incubating them, the more risk there is associated with using a parafilm type approach. And then I think ultimately longer term, you could, if the problem doesn't go away, you could look to move to an alternate supplier, which might solve the issue if it's specifically linked to raw materials or the amount of agar or the specific irradiation doses that they're being exposed to. You could have a look and see whether there's something environmental that's happening at your site. So is it specifically the speed of air that's been blown across the plates? Have a look whether that's meeting regulatory requirements. Obviously, there's less control around whether you can change that or not in order to accommodate the plates you're using. But if there's an opportunity, why not? And equally, you could look to change up the humidity control. So there are some sites where humidity is controlled, and where you are working in that type of environment, you could up the humidity, but bear in mind that also brings risks associated with it. The more water activity there is present within an area, the greater the risk of any contamination being present, being able to survive. So it's a real balance. A lot of risk assessment has to be done, unfortunately, not a straightforward solution. And I suppose ultimately, if your site has sufficient money and you are able to switch out the incubators that you're using, if it's been shown that they're the cause of the problem, it would be worth changing to those that have variable fan speed control. So that will then assist with reducing that fan speed. So you can reduce the amount of air blowing through your incubator. Hopefully it'll still pass validation from a temperature control perspective, and that then might solve the problem of desiccation. So a fair few number of solutions that you can put in place. There are some issues with desiccation. Well, probably the biggest issue with desiccation is how you deal with results of desiccated plates. I would say, this is personal opinion, that the best way to go about it is to invalidate the result. But bear in mind, you now have a gap in your environmental control. And if you look at your contamination control strategy, it will have been designed such that your environmental monitoring plan is a risk-assessed, risk-based approach. And so by having that gap, you need to understand what other control measures you have in place to back up that not having a result there. There's sufficient other data around that could help assure you that your environment has remained in control throughout the period that you were monitoring where you've lost the data.
Tamryn Hassel there. Thank you, Tamryn, for sharing your expert knowledge of desiccation. You can also check out Tamryn's views on the future of environmental monitoring on Cherwell's YouTube channel. If you're an expert in your field and would like to work with Cherwell to create a Delivering Knowledge video, we'd love to hear from you. Cherwell's Delivering Knowledge, sharing insights, experience and expertise from across the industry.